Welcome to this Aspen tutorial. The aim of this tutorial is to introduce you to the National Institute of Standards and Technology Thermodata Engine database, or more simply, the NIST TDE database, as accessed via Aspen Plus. This is a really valuable database of published experimental data for a wide range of chemical systems, both pure components and mixtures. In this tutorial, we'll start by considering how to construct a VLE diagram for a binary system. Then we'll use the database to retrieve binary VLE data. You'll learn how to plot the retrieved data within Aspen and how to export the data to Excel. The system we'll be using throughout the tutorial is ethanol water, a very common non-ideal system. Let's start by envisaging how, experimentally, we might generate VLE data for a binary mixture. Basically, a liquid sample of the binary mixture of specified composition is brought to its boiling point in a still pot and maintained at a constant pressure. Vapour, which is in equilibrium with the boiling liquid, rises from the still pot and passes into the condenser where it cools, and the condensate is collected here. A thermometer immersed in the boiling liquid is used to measure the boiling temperature. The condensate and still pot contents are then sampled here and here, respectively. These samples are then analysed to determine the concentration of the more volatile component. In an ethanol-water mixture in which ethanol is the more volatile component, we might use gas chromatography or refractometry. An analysis of the liquid and vapour samples will yield a single VLE data point. To generate additional data points, the liquid composition in the still pot is varied by adding more of one of the components. The new solution is brought to its boiling point, and the sampling and analysis are repeated. Shown here is a VLE diagram, or XY diagram, for the ethanol water system at a pressure of 1 atmosphere. This diagram was constructed using a set of experimental data points from the 1943 reference source indicated, which was retrieved from the NIST TDE. Note that this non-ideal ethanol water system features an azeotrope at a liquid ethanol mole fraction of about 0.96. Here we have another VLE diagram for the same ethanol water system, again at a pressure of 1 atmosphere. However, in this case, the smooth curve shown was generated in Aspen using the NRTL thermodynamic model, which works quite well for many non-ideal systems. And the shape of the VLE diagram certainly looks similar to the experimentally determined diagram we've just looked at. But we can't simply choose a thermodynamic model and assume that it's appropriate for a given chemical system. We need to be sure. In this slide, the experimental data retrieved from NIST TDE and the NRTL predicted data are presented together. You can see how well they agree, suggesting from simple visual observation only that the NRTL model is appropriate for use for this system at the specified pressure. In this tutorial, we'll now see how to retrieve the experimental data from the NIST TDE. In a subsequent tutorial, we'll consider the use of different thermodynamic models within Aspen to generate VLE data. Now, let's move to Aspen Plus. This screen appears when you run Aspen. As you can see, it presents recently opened models, as well as options on the left-hand side for opening files and starting a new simulation. So let's do that. We go to New, User, and General with English Units, and Create. This is the window that appears when you start a new simulation. There are a number of steps which must be completed in order for Aspen to run a simulation. If user input is required for a particular step, that step is indicated by a red and white circle, which you can see here, and a red label at the bottom of the screen indicating Required Input Incomplete. When you've completed a required step, the red and white circle changes to a blue circle with a white tick. The first step in any simulation is to specify the components involved. You can enter as many components as required, either by typing the component name into the dialog box here, or by searching for a component using the Find button. So let's type in ethanol and hit Enter. Aspen recognises ethanol and has returned the chemical formula for ethanol. To illustrate how the find function works, let's now search for water. Here you can search for components based on class, molecular weight and boiling point. We're simply going to type water in the name or alias box and hit enter. After several moments, a list of components appears, which, as you can see, includes water. Click on this to select it and hit Add Selected Compounds. Now we have successfully specified our components. You can see that the red and white circle, which was shown here earlier, has now become a check mark. Now we want to open up the NIST TDE database. To do this, simply click on the NIST icon in the Data Source tab. Select Binary Mixture and select ethanol and water from the drop-down boxes, and then hit Retrieve Data. Note that it may take a few minutes to retrieve the data. When NIST has retrieved the data, we want to see the results form shown in the background. So we can now close this box and have a look at what NIST has retrieved. An extensive list of datasets is now present in a tab called Experimental Data. The datasets are characterised in terms of the purpose or nature of the original experimental work. For instance, there are azeotropic data, binary diffusion coefficient data, and binary VLE data. In this tutorial, we're interested in binary, isobaric, vapor-liquid equilibrium data, which are presented here. If we click on the heading called Binary VLE, a table appears, which displays summary information for all of the binary VLE datasets available, including the number of data points in the set, the year in which the data were published, and the temperature and pressure ranges used. This is really useful when you're looking for specific operating conditions. Here, we're interested only in constant pressure or isobaric VLE data, so let's click on the heading labelled Isobaric. All of the experimental data sets now shown here have been collected at different values of constant pressure and across different temperature ranges. Let's have a look at the first data set, which was collected at a pressure of approximately 1 atmosphere for a temperature range of 351 to 373 degrees Kelvin or 78 to 100 degrees C, spanning the boiling points of ethanol and water respectively at atmospheric pressure. If we click on an individual data set, you can see that the source of the data is detailed in the pane at the bottom of the screen. Remember that it's always essential to reference a data source. Also shown are the data points and the corresponding temperature. However, for this dataset, only liquid mole fraction data are provided. So let's choose one with both liquid and vapour mole fraction data. Let's try dataset 52, which was collected at the appropriate pressure and across the appropriate temperature range, and which includes both vapour and liquid mole fraction values. Now, we want to visualise the vapour-liquid equilibrium relationship, so let's plot the data. If you move up to the Plot section in the Home ribbon and scroll through, you'll see that there are several graph options available. Let's select YX to plot a simple binary VLE diagram equivalent to the diagram we saw earlier. Here, as you can see, Aspen labels the graph and includes a simple heading and legend. On the y-axis, we have the mole fraction of ethanol in the vapour phase. On the x-axis, we have the mole fraction of ethanol in the liquid phase. Closing this graph, let's now look at a TXY plot for the same system. Now we can see the temperature is plotted on the y-axis, and the ethanol mole fractions in the liquid and vapour phases are on the x-axis. While these Aspen plots provide quick, useful visual checks, if you want to customise the graphs or to compare VLE data from different sources, the best option is to copy and paste the data into Excel. To select the data, click on the top left corner of the table, right-click and hit Copy. Now simply paste the data into Excel. The data can now be plotted with the liquid mole fraction on the x-axis and the vapour mole fraction on the y-axis. That concludes our introductory tutorial on the use of the NIST TDE database in Aspen. In this tutorial, we've seen that published experimental data can be accessed on Aspen via the NIST Thermodata Engine database. These data are organised on the basis of the purpose or nature of the original experimental work. In our case, we were specifically interested in isobaric binary VLE data. Finally, the data can be easily plotted in Aspen and/or in Excel. To plot the data in Excel, copy and paste the data from Aspen. Thank you for your attention.